Hey everybody, this is Mr. Stansberry. We went over this in class, but I know that some of you didn't get the notes for whatever reason, so I want to share this with you so that you can keep up. Uh, our mission objective today is to know the arrangement and movement of particles. Determines how matter behaves in solids, liquids, and gases. That is our mission objective and our learning target. All right, what you were we had to do now today on the definition of matter, and we've covered that. So we're going to talk about your interactive notebook activity. All of you were given a foldable that looks, well, you can't see it, looks just like this. And on the inside, it looks just like this. So we've got it all put in our notebooks now. We went over this particular video here on how to do the inside of it or the outside of it. And you can watch that at your leisure. We watch it in class, so to kind of help you kind of get going. But I want to talk about the inside of the particular video of the ISN. So the first one is we talk about solids. So we'll look at its shape, its volume. I want you to draw an illustration of something here that we can kind of look at so that you'll put some things in here. All right, so what is the shape? Is it definite or indefinite? So if we look at something that's solid, does it have a fixed shape? Well, if we look back here, it says that particles are packed together. That means that they have a fixed position. That means that it has. So what we would have now is a very definite shape. All right. So if we have a volume, well, since it's held together by forces, it's packed together, it's a safe bet that it's also very definite volume. Now I want you to draw some things in here. So if we're talking about something that's solid, we could almost just put the molecules really tight together. And my drawing, I know, stinks, but you get the idea. All right. And the other information here, the particles are packed together in relatively fixed positions, would go here, held together by strong attractive forces, and they only vibrate at fixed points. If you need to pause the video right here, feel free to do so. Otherwise, we can move right on. All right, now we're talking about liquids. So let's get out this. We don't need this picture now. All right. So liquids, we're talking about liquids. Does liquid have a definite shape? Well, liquids will take the shape of their containers. So because of that, let me get this off here. Using a new program, so learn how to use all the parts of it. But since we know it takes the shape of the container, that we then know that the shape of it is, what do you think? Definite or indefinite? If you said indefinite, you're absolutely correct. But because we can weigh it, we know how much it weighs. We have an idea. We know that its volume then is definite. Of course, I want you to draw an illustration here and put this extra information in the other info. So take a minute and kind of do that. Pause the video if you need to, or you may have been writing while it was there. Doesn't matter. We're moving on. Now we're talking about gas. The particles move very rapidly. They're a great distance from one another. And this makes the attractive forces not hold them as easily. So I guess the question is, does gas have a definite or an indefinite shape? Well, if liquids have an indefinite shape, well, it's safe to say that gas has an indefinite shape. Now, we know that liquids have a definite volume, solids have a definite volume, but because gas can move around and the particles have such movement, it's safe to say that volume has an indefinite, because you can compress the gas, expand the gas, and that will impact its volume. We'll talk about that later on in the class. And then, of course, this information will go into your other info piece. Okay? Easy so far. The fourth one that we really don't talk about much is because it's relatively new. When the three states of matter were put together, We didn't understand how all things worked as far as one temperature. Now, you know that your overall learning objective is understand how thermal energy impacts the way the states of matter respond. So, in the next order, we have plasma. Well, plasma doesn't have a definite shape, it has an indefinite shape and an indefinite volume. It's a high temperature. The atoms, because this, lose their electrons, and it's what you find in the lights that's above us in the classroom. Those are fluorescent bulbs. That's a gas that's being held at a very high temperature. And if you remember, as we looked at this, as the energy increases, that changes the states of matter. Now, you need to have this in your ISN because when we take our next open note test, you'll have to answer questions and you can use this as a reference. Remember, though, my tests are not regurgitation, they're application. They're not regurgitation, they're application. All right? Good job today. Get this done. Have a good night. We'll talk to you later. Have a good night. Bye.